Good evening to all of you for today's session.
Good evening, sir.
Yeah, good evening. Yes, actually, myself Anil Madik. I'll be taking today's session. Today's brief agenda. Can you see my screen?
Yes, sir.
Yes, sir.
Okay. I hope AutoCAD session has already started. I think on the Saturday and Sunday. I think.
Yes, sir.
Right. Yeah. So I hope everything is going well, and all of you have installed the AutoCAD software also on your machines.
Yes, sir.
And you are practicing on that also, whatever has been told to you, basic study. In the beginning it may happen that the things will go very smooth and slow, and have patience in that, because initially the things are we are streamlining the things, and you are also new for the training program, and have patience on that. And I hope you start gradually and slowly on the sessions which we are doing. First of all, I would like to tell you one thing, that you are having alternate day sessions almost. So when we have the session today, let's say, so please rehearse and practice on the next day. And if you get any doubts or anything regarding that on that day, you can discuss with the trainers on the next day. And prepare your notebook where you can practice and where you can put your questions on the notebook. Okay. So we'll start. I'm going to discuss today on just a moment. Yes. Yeah. Brief agenda today is I'll discuss about whole to part study. Then holistic picture. What is meant by holistic picture? And learn as a whole from first, or we can say, and then parts. Okay. Then life cycle of civil engineering projects I'm going to discuss today. What is that? Let's understand first. All of you are now familiar with our company, SCCC. I'll just brief you about that and we'll go ahead. SCCC is a well-established design and construction firm, which is dealing with industrial construction works, structural consultancy services, which are in high-rise buildings, low-rise building, commercial buildings. We also deal with the value engineering services, structural audits and retrofitting, and in different RCC structures, steel structures, buildings, water retaining structures and all. And all of our training program is actually dealing with these all things only. And if you see to the our services which we are giving to the clients, our training program is also structured within that framework, so that you can get overall experience within 1 year and get the good experience with respect to the training program and with respect to the practical aspects of it. Now we'll have a little interactive sessions today, where you will be also giving your opinion in that. Just a moment. Okay. Can anybody tell me what is meant by whole to part study? Hello. Yes.
Sir, I think it will include all the civil infrastructures as a whole, and
Okay.
from that, if you'll pick some water segment part like industrial structure part as well as the residential project part, that will be termed as part.
Okay. Anybody else? Any your opinion, ideas, or views on this? Hello.
Hello.
Yes, Mr. Amit.
Yes, sir.
Yeah.
So it is in a learning technique in which we broke all the matlab, study material into separate pieces
Mm-hmm.
to complete whole the thing.
Mm-hmm. Okay. Yes. Anyone?
Studying a technique in different parts.
Okay. Yes. And I will just actually what I mean by this. Take a simple example first, so that see somebody is asking me. Let's say that what is your address? So I may say that I'm staying in, let's say, Pune, or say my house is there, my house name and nearby landmark. I think so. This is also one of the way. If somebody asks me where you stay or where is your office, and there is one way of telling my address that I am in this, say we can say solar system, in which there is a planet which is Earth. On the Earth, I am in Asian continent. In the Asian continent, I am staying in India. In India, I am staying in Maharashtra, and in Maharashtra, I am in Pune district. And in Pune district, I am situated in Chinchwad city, and in that, I am staying in so much of that address. So, see, when I started thinking and giving that address to a person, I thinking in the universal part first. So solar system, and then I broke down into then our sun, then our earth, and this so much. So whenever we learn the things, let's say you are working on a project, or you are learning this. Now our training program, if you look at our training program, it is quite big training program, and when we learn that, we may not be in a position to understand actually what we are learning in this training program, because generally what happens in colleges, which whatever we learned first year, second year, third year, and fourth year. We learned a lot of subjects. I think around 30 to 40 subjects we learned. And some of you may not be in a position to understand actually how the civil engineering is working. And whatever we studied in the first year engineering mechanics, then maths 1, maths 2, maths 3. Then we learned strength of materials, quantity survey, then we land surveys. There are a lot of subjects which we learned actually, but if I ask you to connect them together, you may not be in a position to understand actually what is the significance of each subject, and actually what is the civil engineering itself. We may be in a doubt, or we are not yet clear about our subject, our field which we learned. And that happens actually many times, that we are not trained to learn the things in a holistic picture, we can say. And whenever we lose the holistic approach in our study, or in our learning, or in our application of the projects, we may lose a lot of things actually, and we may not be in a position to take the good decisions. See, as our training program is in the civil engineering sector, and we will be working on the projects in the career. And if you don't apply this holistic approach in our career, it may happen that we will not take good decisions. And to understand that, we should know what is holistic part. That means we should learn as a whole. So for example, we now this is our training program, uh, which we have launched. If you look at our training program, then you will see that we are covering different sectors in our training program. Okay, so we are covering, let's say, just a moment. Okay. Okay. Now, so actually we have divided our training programming high-rise building sectors. Then we have divided our program in steel structures. Then what we are doing into the water retaining structures, and we will be working on the audits and retrofitting. Okay. So if you look at the structural our training program which we have we are not saying that we are learning the ETABS. We don't say that we are learning, let's say, STAD Pro, or we are not saying that we are learning. See, whenever you, I think all of you have joined our training program. Many of you are aware of this ETABS. Many of you are aware of the STAD in pockets, in parts, or maybe some other softwares like SAFE or whatever other softwares which we are dealing. But are you really aware of what is the high-rise building sector? Because this is the sector which is in existence in the market. So whatever companies are there in all over the world, they are working. There are few companies who are working in high-rise building sector, who are working in industrial steel structure sector. There are many companies who are working in water retaining structures. That means treatment plants, domestic water treatment plants, and structural audits and retrofitting. So as our training program, we have structured in the holistic part first. Because unless you understand, if you only learn the STAD, if you learn only ETABS, it is of no use actually, because you may not understand actually why I am learning the ETABS and where it is used in totality. So in totality, we should understand what we are doing. See, it is a part of the system, definitely, yes. We are going to learn ETABS, but you should know what is happening behind and why I'm learning the ETABS. So if I consider high-rise building sector itself as, so my thinking starts from high-rise building. So yes, there is one client who wants to construct a high-rise building for, let's say there is a builder or a developer, or there may be some mega cities. He wants to do the high-rise building design. So he wants to do the high-rise building construction. So what are the people who are involved in that? There are architects, structural engineers, geotechnical consultants, and so many people are there. Okay, now we are working in a structural consultancy company. So what structural consultancy company is doing? So what they are doing? So what is the process of work? So yes, structural consultancy people are doing the high-rise building design, and what they are doing? They are giving the drawings to the clients. So to prepare the drawings, what are the steps involved in the work? So yes, there are steps that they do the study of the project, they do the geotechnical investigation study, then they do the design basis reports, then they do the general arrangement drawings using the AUTOCAD, then they do the ETAP modeling to calculate the forces. Once they do the ETAP modeling, they go for the design in the RCDC software. Once they do the RCDC design software, they do the Excel design for verification of the results. Then after that, they prepare the structural drawings. And finally, the structural drawings goes to the site. And during this, they are following different Indian codes, which we should follow as for the safety purpose, we can say. So there are a lot of things involved in the system. So we should not only focus on the ETAP software, or we should not only focus on the AutoCAD software, which we are learning. Yes, it is a part of the system, but you should know how the system works, how the high-rise building companies are working. So we always start from that, and then we will learn the pockets or in parts. Then we will learn ETAP software, then we will learn SAFE, then we will learn RCDC, then we will learn, there are a lot of things actually. So whatever training system we are doing and whatever the projects are done in the market, they start with the holistic approach first, and we divide them into the parts, and then we will learn. Then whenever you learn in parts, you understand why I am doing this. What is the purpose, and what are the total systems, and what are the total people involved in that, and where I am doing work. So this is the holistic approach, and please keep this holistic approach and develop your thought process such that you learn from whole to part. Okay. So this is one of the important systems actually during the college we learned in the parts only, and nobody has tried to connect their dots. There are missing links. We learned so much subjects, but we don't know how they are connected with each other and what is the significance of those civil engineering subjects in the market. So now during this training program, we are trying to connect these dots, connect these missing links. And we are here to develop a thought process, which is really required to do in the projects and to become a good structural and civil engineers. Okay. So that is the purpose of this point, which I am trying to note. So to start with ahead, I will discuss you regarding the life cycle of civil engineering projects. The aim of this today's session is you'll understand holistic part of civil engineering projects, and then we can understand how our training program will be going ahead. Okay, so let's start with this. So first, definitely, we should know what kind of projects are there. So anybody will discuss what kind of civil engineering projects are there. Anybody? Let me understand in civil engineering what kind of projects are there. What you know means. Let it be random, doesn't matter, because as you are learning and
So project regarding transportation sector,
yes,
industrial infrastructure.
highway,
yes, you give me the typical part means we can say yes, transportation. What kind of projects are there?
In transportation, sir, rail infra and road infra, sir.
Yeah, so road infra means there is a road, there are bridges, there is a railway,
Yeah, rail
there
infra.
may be metros, there may
Yes,
be, or we can say airports,
Yes, sir.
and so many things. There are many things, dams. So it is something related with the transportation, or we can say dams are not in the transportation exactly, but okay, railway, airports, and roads, bridges. What else?
Yes, sir. And sir, high rise in
Yes.
Hello.
Okay. Let's.
Sir, in water
Yes.
and wastewater sector, we have different structures like
Yes.
water treatment plant
Yes.
and wastewater treatment plant. Another thing, overhead tank and groundwater
Yes.
reservoirs
Yes.
and pump
Correct.
house.
Yeah. Yeah.
All
Yeah.
these things, sir.
So in water sector,
And also
yes.
irrigation sector, we have to also like different structures like river training works and all these things.
Yeah, in the dams we can say yes.
yeah.
Yeah.
Yeah. What else?
In infrastructure, sir, high rise building, residential, maybe commercial.
Yeah. 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 So for staying office for offices we want commercial buildings.
Yeah.
Then we for residential purpose there are high-rise building, mid-rise buildings, or bungalows.
Yes,
Then so that means building is one of the big sector, and there are different building projects.
yes,
Then there may be retaining walls. So this is something related with the building sector. One is related with the water sector.
yes.
One is related with the transportation sector. And what else? Any? One of the important sector, that is industrial sector. What kind of projects or what kind of structures are there in the industrial sector?
Chimney, sir.
Yes, chimney.
Conveyor works, maybe it is in a part of mechanical engineering.
Yes, conveyors or bridges, pipe bridges, pipe supporting
Yeah.
bridges.
Yes.
Yes, conveyor. Then yes, gantry girders
Sir,
means to
gantries.
support the cranes in the warehouses. Yes, so warehouse structure is there. So why warehouse is used? For what purpose? Or sheds, we can say industrial sheds.
To-
Uh, Sir, for storing finished
Yes, for
products.
storing the finished products. Then there are industrial sheds. Why they are used, or what are the different purpose for which it is used? Industrial sheds.
for being a workshop, sir.
Yeah, for workshops, manufacturing,
Yes.
There are say industry people are manufacturing the products. Let's say it's a car, it's maybe a bottle, it may be there are different parts which we products are there, actually different types of projects. So car, it may be car, or it may be parts of the car, it may be anything. Means there are a lot of products in the market which are with respect to, we can say, transportation, with respect to food and a lot of things. So for that process, manufacturing process, they require the warehouse sheds. Then there are administration buildings where the office people are working in the offices, in the industrial structures. There may be retaining walls for retention of the soil. There may be we can say security cabins. And see, have you seen any industry before? Have you visited any industry?
Yes, sir. I have
Yeah.
visited Tata Steel Kalinganagar, NTPC
Yeah.
Raigad,
Yes.
OPGC Jhansuguda.
Hmm.
I have visited many industries, sir.
Right. So there are many industrial structures which are involved. What else? With respect to electrical, we are having transmission lines,
Yes, sir.
transmission line towers, and so on. So if you look at this, so there are a lot of structural engineering and civil engineering projects.
Sir, in hangar building, also some places gantries are there.
Yeah, there are a lot of features actually. Gantries are different kind of gantries are there in the industries. It may be, as you were saying, hangar, then it may be EOTs, or there may be some, you may be saying the construction people are using cranes. That is also gantry cranes, we can say, gantry cranes. So a lot of structures are there in civil engineering, and that means as a civil engineering, actually, we should be happy actually that we are having a lot of opportunities in the civil engineering. So these are few, actually there are many more what we discussed: buildings, industrial sheds, water treatment plants and water tanks, and so many things, chimneys, bridges, retaining walls, and so on. There are a lot of structures. Now, if you look at the structural part of this, so now our aim in the training program is definitely civil engineering is very big sector and very big and vast field. We are here to develop our thought process such that wherever we go, whatever career we choose, we should fit in that career. Because let's say if you do the building, if you do the industrial shed and this, then whatever may be the industry we are working in, we should be in a position to take the pickup and make use of all this knowledge what we are getting in our training program, such that you are confident enough that you can absorb in any industry very comfortably, because your thought process is already developed. Your confidence is already developed by learning this. Okay, so this is our aim. So thought process is one of the holistic word, and it's very you'll come to know gradually, because it's a long-term thought process is not something which you can develop within 1 day, 1 month, or 1 year. It takes a lot of years actually. But right thought process we are trying to develop within this training program. So try to understand that what is right is something very subjective matter actually. But during this training program, during the discussions, during our learning, during our say interaction, learning a lot of softwares, basics of structural engineering, and so on, we will be developing this thought process, which is really required in the practice. So practical knowledge gets developed through the appropriate and right thought process. Okay. So types of projects we discussed. Now, in civil engineering, we do a lot of projects actually, but in general, the life cycle is same or similar, we can say. So, you know what is meant by life cycle? Can anybody tell me what is meant by life cycle? Life cycle. What is meant by life cycle?
No idea, sir.
What is meant by life? Let's say general term.
Sir, is it from the starting to end of the till handover of the finished product?
Yes. So start to end. Let's say as we have taken a birth somewhere. Then we are now becoming younger, then child to younger, younger to old, within this time frame, and we finally get dead. Okay, within this our lifespan, we are doing a lot of things, right? So start and end, we can say start and end. And during the start and end, there are a lot of processes and there are a lot of happenings between this. Okay, so the journey of life, we can say. So this is, as it is applicable to the person, it is also applicable to the projects. So there is a life cycle. We construct a building, so we do the planning, we do the construction, and after the construction, we are supposed to do the maintenance, and the structure becomes so old that we need to demolish. And once it gets demolished, then there is again a plain land, and we again reconstruct the new building, we can say, and again it starts with the plan. So this is, we can say, life cycle, and for any projects there is a life cycle, we can say. So we'll learn one, understand this concept of life cycle through one sample project of building, so that it will be clear. Now this is a life cycle of, let's say, we'll take an example of building. So for construction of building, what you require?
Land.
Yeah, so we require a land for construction of building.
Material.
Yes, so we require land, we require a material, right? Construction
Labor.
material. Yes.
Labor.
Sir, 3M, manpower, money, and resource, sir.
Yes, so there are three: material, money,
Manpower and
manpower. Okay.
yeah.
Then what we
And
require?
after searching of land, first of all, you do GTI, sir, for soil testing.
Yes,
So
yes,
now bearing capacity of soil.
yes, yes,
Then you needs a planning, architectural plan, what you have to do.
yes, yes. So we require a land. So definitely there is a client who wants to build a construction, build a project. So let's say we'll take an example of builder or developer who wants to construct a high-rise building. Let's say he wants, because he wants to construct a high-rise building. And definitely for construction of high-rise building, we require a land. Generally, the client is having a land with him. He is having a money with him. Definitely, without money, nothing is possible. So money is required, land is required. Now, on the land, we want to construct a high-rise building, HRB, let's say. HRB, okay. So this is not enough. Client is not competent to do this construction. He is only having money and land. So what he requires, one geotechnical consultant who will do the soil survey, we can say. Then he will appoint an architect who will do the architectural planning. Then he will appoint a structural consultant who will do the structural framing, structural analysis, design, and drawings. Then he will appoint a contractor who will do the construction of building. Once the construction of building is done, generally it is handed over to the client or society. So what he will sell the building to society or the people. Let's say he's selling the flats. So all the flats will be sold out, and the people will develop a society. And this society will do the maintenance of the building over the years. 5 years, 10 years, let's say 15 years, 20 years. So he will do the maintenance, the society will do the maintenance of the project or building. And after say 15, 20 years, they need to do the structural audit of the building, because see, as the building gets old, we need to check its health and strength. So to check the strength, we need the structural audit. Many times building may not be in a position after 20, 25 years. Some columns may be weak, some beams may be weak. So we should check whether the beams are right or columns are strong. And after that, there is a possibility that some columns are weak. So we need to strengthen the columns or beams. So we need to strengthen or retrofit the columns or beams or slabs, whatever the structures are there. So we will strengthen the building through retrofitting process. Let's say after 50 years, 80 years, 70 years, depends on the quality of the construction. The building is very weak, and even retrofitting will not be sufficient, because the cost of retrofitting will be too much after 80 years or 50 years. Then finally the client decides to demolish the building. And after he demolishes the building, again there is a plain land available to do the new project. redevelopment project, we can say. So it started with the plain land, and through these processes, it traveled over its life. And after the demolition, again, that building is over now. It started somewhere, let's say 2001, it started. Land was there. The building constructed in, let's say 2005 or 2003. And let's say in 2050, the building got demolished. And in 2051, again, new project started, 2051. So this is called as the life cycle of the project. So any project actually generally is within this framework only. Generally, there may be some additional points, but this is the overall project life cycle. And we should understand this life cycle first. So whenever you do, let's say I am doing the ETAB analysis. So if I ask you see, many people know, I know ETAB software, okay. But if I ask you actually where it is used, and where is the role, what is your role, where you are working, can anybody tell me where the ETAB software will be used in this life cycle? And who will use, in which company it is used? What is your role or job profile? Where ETAB software will be used?
Structural analysis and designing, sir.
Yes. So in this zone, we are using that software, right? If I ask you where the sanctioning of the drawings are done in the, let's say in the corporation, sanctioning is done of the drawings, where it is done, and who is doing the sanctioning of the drawings, or who is submitting the drawings to the corporations or town planning authorities?
Sir, a structural designer generally submitted drawing.
Yeah, structural drawings are submitted and architectural drawings are also submitted. So these are the two things which are submitted in the corporation. Who is doing the structural audit?
A structural engineer, sir.
Structural engineer, definitely. Now, these are the things. Actually, I'm asking randomly questions actually, just to relate the life cycle and relate whatever we are trying to learn. So, once you understand this, definitely you should understand in detail also. Now, let's try to go in detail of each thing. So, let's try to understand what is client, let's try to understand what is land, what is geotechnical investigation, what is architectural planning, and what is their significance, role, importance, and so on. So, we'll go in detail now. Once we understand this total picture, let's try to go in detail of each part. Okay. So let's move ahead. So what is a client? Who is a client generally? Do you know? I'll ask first question and then we'll go to that. Who is a client? Or what is client?
To whom, sir, we have to submit the final project? Owner of the property, sir.
Owner of the property, right? Yes. Anything else? Who can be a client?
So it may be any individual person, or it may be any government organization as well as private organization.
Right. Yes. So it may be an individual owner who, let's say I'm an individual owner and I want to construct a bungalow. I want a bungalow for myself. So it may be an individual owner. Let's say I want to stay in a good bungalow. It may be a builder or developer who is doing the township of high-rise buildings, township of say small buildings, apartment buildings. So he may be a builder. So he want to construct a say high-rise buildings and he will sell out to the customers. Or it may be a government. So you know that there are a lot of government projects which are owned by the government. So see, the roads are owned by the governments, bridges are owned by the governments, or there may be some government buildings like Mantralaya and so on. There may be government buildings, railway is a government property. A lot of government projects are there. So government is a client for us. Then industries, there are many industries, let's say car manufacturing plant like Tata Motors. So he is owner, he's a client. So we can say him as a owner or we can say him as a client. Trust like educational colleges, we can say school buildings, educational buildings like colleges, and maybe some trusts like NGOs or temple trust, or there may be many trusts are there. So these are clients. So these are clients for us. For us means I don't know where I am there as a structural engineer or structural consultant. There are many consultants involved in the projects. It may be structural consultants. What else are there? Who are the consultants which are involved in the projects? Any idea? We know architect, we know structural engineers. Anybody else who are involved in the projects? Any just
Sir, services consultants and some quantity surveying consultants also.
yes. So we can say estimation or project management consultants who are doing the estimation, who are doing the quantity survey. What else?
Sir,
GTI
services.
consultant.
There are architects, there are structural consultants. Yes. What else?
GTIs and planning section.
Yes. Geotechnical consultants,
Pla-
Sir, MEP services consultant also.
MEP, sir. So mechanical, electrical, and plumbing consultants. So these are there. Else, any? Landscapes architects. These are special, we can say, landscape architects. There are building architects, there are landscape architects.
Sir, safety consultants.
We can say safety, yes.
Sir, interior.
Interior consultant, we can say, yes. It's a part of subsidiary part of the architect, but let's say they are separate also many times. Interior designers, we can say, okay. Then contractors is also one of the part of the stakeholders. So generally consultants, or we can say stakeholders. Do you know this word stakeholders? Whoever is involved in the projects, we can say them as a stakeholders. Contractor is a stakeholder, consultant is a stakeholder, architect is a stakeholders. Or there may be some, it depends on the different projects actually. Building we are having, maybe having, do you know ISO consultants are also there? There are CAs also who are looking at the financial part of the projects. So many people are involved in the project, and those all are working for this client. So client is one of the important part of the project. So he is finally giving the money to these people, right? So whatever money is there with the client, it is being given to all these people as per their percentage of work and their roles, right? So client is one of the important part of the project because the idea is in his mind. Because the project comes in his mind, I want to say construct a high-rise building of 40 story. And I'm having a money with me and I'm having a land with me. So can you help me to complete my dream? So that is the client actually is very important part of the project. Then to complete his dream, now these all people are working. Architect is helping him to do the planning, submission, interior design, and so many things. Structural engineering is helping to make their structure very safe, stable, so that there will not be any problem to the structure throughout its life. And other people are working MEP, mechanical for AC and so on. So there are a lot of people, electrical people are making sure that there is a light available to the building, all this generator and so many things. So this is one of the important part of the stake project. Then we'll move to the next part, which is nothing. What comes? So what are the things which we require in the land? There is a plain land. What we do on the plain land? Do we directly jump onto the project construction?
Land survey, sir.
Yes, land survey. What are the points which are involved in the land survey?
Labeling of land, sir. First of all, we take label sheet, sir. After that,
Yeah.
after that, sir, we are going through GTI work, sir.
Yeah. So in the whenever we check the levels of the land, existing land, natural levels, what we use in the leveling? Checking
Dumpy level, sir. Dumpy level, sir.
Yes, so we use the dumpy level, we use the auto level, or we use
Total
the
station.
total station. Total
Yes,
station.
yes.
So this is important. And who is doing this survey?
Surveyor, sir. Surveyor.
Engineer can also do, sir.
So what kind of qualification he generally holds?
Generally, sir, he holds diploma degree or ITI holder, sir.
In civil engineering, right?
Yeah.
Sir, sometimes non-technical people are also very good, skilled in doing surveys.
Yeah, non-technical they do, but finally the general responsibility goes to the civil people only. He may be diploma or be civil, because finally these are the quite important part, which is we can say field of the civil engineering. We can say. So, and after the levels, what we do after taking the levels?
Transferring the, if we have a drawing, then we transfer the points of the drawing on the ground.
Yes. So whatever the levels are there, we transfer it on the paper, and on the paper we draw the contour survey drawing. Do you know this contour survey drawing?
Yes, sir.
So contour survey drawing we prepare, and what is the use of contour survey drawing for us?
Sir, we can know where we have to cut or where we have to fill, or what is the existing gradient of the slope of the terrain.
Right, right. So existing terrain of the we require to understand, because see, whatever planning we are doing, architects are doing the planning. So they should know the natural ground level so that they can plan their building accordingly. And there is one point, that is cutting and filling. So why cutting and filling we require actually? What is the purpose of this? What is the use of this cutting and filling? And what do we really?
Irrigation, sir. Canals. Irrigation canals.
So let's say let's take an example of building only. Why it is required to understand the cutting and filling? What is the use of cutting and filling?
So cutting, filling in structural work for foundation work. Hello.
Yes, yes.
In foundation, sir, we generally do cutting and filling. First of all, sir, we make a plain ground, sir. Do leveling.
Yeah. So let's say I'm having a ground like this. Okay.
Yeah. For leveling purpose.
So, and let's say architect is intending the plinth level like this. Let's say. So there are different buildings, let's say like this. So this is my plinth level of a building, and there is a building like this. Okay. There will be foundation like this. Okay. Because we have to raise the foundation on the hard strata itself. And now this is my natural ground level, and this is my, let's say, plinth level. Let's say this is my plinth level. So see, this is my plinth level, and I need to level this ground first, right? To level this, definitely, if this is my natural ground level. So if I know that these levels on the paper through the ground, then definitely I will understand that, let's say now, there is like this ground like this, let's say. Okay. So once I know the levels, definitely I can make sure that whatever is the part here, I can cut. See, to fill this portion, valley portion, I need some soil, murum. So either I can import that murum from outside of the site, from somewhere else, or I can cut this part and fill this here, right? So that I am utilizing this, and there will be a plain land. So this, I need to develop a plain land out of this, correct? Because generally for any project, plain land is a really good choice. Then what will I do? I will cut this part, and I will move this, and then I will fill this level such that this what magenta or pink color line is there, and there is a plain land. So this is called as land development. So once I understand this, I can optimize the cutting and filling quantity so that I can optimize, rather save my money. Will it be okay that only import all the murum from outside and purchase that murum and just fill it? It's not a good choice. So whatever this pink line, I can decide from the contour level such that there will be optimization of cutting and filling quantities, so that I need not to import the murum or soil from outside, and I can save my money. So this is one of the point. And second point, once I decide this level, I can understand what part should be cut, what part should be filled. and what is the volume required to cut and fill, and to say calculate the quantities, and then do the budgeting of that cutting filling. Then I can understand the even this foundation part also. So is now when it is a filling part of the soil. So once I understand this is the filling, and that means my plinth, whatever plinth is there here, so I need to support that plinth, and there is a weak soil below this. So filling portion is generally weak. So structural engineer takes care of this while he's planning that there is a filling work, and I need to support the slabs or beams on that safely, because I know that there is a filling after this cutting or something. So there is an architect who can decide the plinth level on the basis of this contour survey drawings, or there is a structural engineer who will take care of this, let's say slab above that filling safely. Okay, so this is the part of use of the contour survey for the architects, for the structural engineers, and cutting filling for the civil engineers who are on the site. So site engineers or project management consultants can use this contour survey drawing and optimize the cutting filling quantity. Okay. So this is something related with the land survey. So once we get the plan land from the client, we are doing the land survey. We means surveyors. What else after land survey? What comes after land survey? Geotechnical.
Architectural planning.
Geotechnical investigation generally we do before the planning, or architecture planning and geotechnical investigation is done parallel, because architect is some different agency and geotechnical consultant is different agency. So what is the geotechnical investigation? What we do and what is the use of it?
Soil penetration test to find out the bearing capacity or different strata or the property of the soil.
Yes.
To find out the property of soil by using boring.
Yes, boring.
And collecting the sample after 1 meter interval.
Yeah.
And taking into lab and submitting report of load bearing capacity of soil.
Yes. So one of the important
load bearing capacity and water table also we need, I think.
Yes, water table. Yes. So these are very key point, important point. So we want the and who is using this data, whatever water table or let's say soil bearing capacity, who is using this? Why it is used?
Designer, sir.
So structural design of foundations. So soil bearing capacity is nothing but a capacity of soil to take the load, and the load is coming through the foundations, RCC foundations. So design the foundation, RCC foundation, we require SBC. Foundation design of any structure, it may be building or any other structures. So this data is required for design of foundation. Then somebody said water table, groundwater table. Why it is required? Where it is used?
Sir, sometimes when we go for any construction of any building, so if water table is high, so there is pressure of water in the to the footing, so the structure is unstable.
Yes.
Due to the water pressure.
Let's say.
Hello.
Yes. Please.
So if there is water table, there will be changes in the bearing capacity of the soil, as well as there will be uplift pressure.
Yes.
That will act on the foundation. So these factors we have to consider.
Yes, sure. So let's say I want to construct a high-rise building, and there are two basements, because when there is a high-rise building or commercial high-rise building, we need underground basements. So do you know this underground basements? Below the ground, there are two basement, one basement. Let's say my water table is over here. So there is a water coming. That means due to this water table, there will be uplift pressure on the raft. Or see, definitely whenever we go down the below the ground, we need to construct a retaining wall, and we need to construct the raft, basement raft. And as the water is above, there will be pressure of water on the raft and on the retaining wall itself, right? Triangular pressure. And due to this pressure, then the structure will have the stresses in the concrete and steel, right? So
Yes.
to design the retaining walls for the water, to design the raft for the uplift pressure, we require to understand what is the height of water below the ground, or this we can say below the ground, what is the height of or water level we can say. So this is required to design the foundations we can say. So raft is a foundation. What pressure is coming? Then so that means SBC we understood for the foundation design, footing design. Then we understood water table. It is said throughout the year because generally in summer season we may be having water table below. So this may be the water level, let's say in summer, but in rainy season it may go up, and definitely worst condition is rainy season. So we should generally check in the rainy season water table so that you can get good or correct data. Anybody aware of subgrade modulus?
Yes, sir. Sir, it is the uplift. It is the capacity of the soil to means it is the pressure of the soil. That is means the strength in the soil that is due to its engine means due to the water present in the soil.
Oh, it's not actually water, it's itself only soil subgrade modulus. So let's say this is your soil, and let's say I'm putting a foundation on that. This is my RCC foundation. So what, due to the load, what happens? Soil gets displaced. It will deflect, not displace. There will be some displacement due to the pressure of the foundation on the soil. So that means subgrade modulus is the stiffness of the soil. So if your soil is stiff, it will displace less. If the soil is weak or less stiff, we can say, having less stiffness, then it will displace more. So as our code is saying that our displacement in the soil should be 25 mm. So to calculate the displacement of the soil, we should know what is the stiffness of soil. So that is the stiffness means subgrade modulus. We are going to learn that in foundation part in our training program somewhere in between. So there we'll learn what is this. So there are a lot of things we are going to learn in our training program. Okay, so try to understand in general and bulleted points only, because in detail we are going to learn a lot of things. Now, what is meant by flood line data? Do you know flood line?
Yes, sir. Sir, when we go for any means design of any bridge, so we used to we need to have the data of the flood level and maximum flood level and other hydrological data.
Yes, yes. For
So
example, yes, if I want to construct a bridge, let's say I'm constructing a bridge like this on the river. Let's say this is my river. This is my river, okay. This is my water. Now, let's say generally in summer and rain, this is my water level, which doesn't go much high. And this is my bridge. But during say 50 years of lifespan, there is a possibility that my water will go till this level. So that means, let's say sometimes in 50 years, my water is going to happen and this bridge will be of no use in that case. There is a problem to the traffic. So let's say 50 years back, there was a flood line level over here. This. So will you really construct this build at this level, whatever I shown? Definitely, I should go above that. So I will definitely construct a bridge like this, so that in any time lifespan, there is a not possibility of the water will go till the top of the bridge, right? So this is required for this, even for the buildings also. See, generally there is a river. Let's say this is a river. This is a river. Okay. So the buildings are constructed near the river, but such that they are not in the river. Let's say flood line. Say this is my flood line. Let's say. So we are not allowed to construct this building actually because it is going in the flood line. So the water will go in the during the flood in this building. So generally, during till this line, the construction of the building is not allowed. So in general, in town planning authority and department, these drawings are there, flood lines and everything. So all architects are planning the buildings beyond the flood line. This is, let's say, my flood line. This is my flood line. Actually, I'm showing in section. if you see the river, this is my river, let's say, flowing like this. And this is my flood line. I can construct the building beyond the flood line. Let's say this is my building plan. Okay. I cannot construct the building within the flood line. So this is my river edge. And this is the zone within the flood line. I cannot construct this part. I can construct in this. So to understand this, we need the flood line also. See, do you know Tata Motors plant? Any idea? The news regarding the Tata Motors nano plant. Tata Motors nano
Yes,
plant.
it was shut down.
Where it is now? Nano car plant.
Gujarat, sir.
Yes, now it is in Gujarat, Sanand. Right. Do you know what was the first location of the nano plant?
West Bengal.
West Bengal,
Singur.
Singur. Right.
Singur, sir.
So do you know, whenever they constructed first plant in the Singur nano plant, all plans were generated actually, all structural design was done, and they even started the construction of the buildings of warehouses and manufacturing sheds and so many things. So what happened? There was a hilly and sand, marshy land. There were warehouses. They started the columns actually first. And this was the plinth level where the manufacturing was supposed to be done. And actually, so just a moment. The columns were casted, foundation was done, piling was there actually due to the marshy land and weak soil. So there was a piling, and these columns were coming, and after that we are supposed to do the structural shades like these pre-engineered buildings and trusses and so on. And this was the plinth level. Okay, plinth level was around say 2-3 feet above, so it was quite above, and this was the natural finished ground level. During that, I think I don't know, remember that time, there was a huge flood, and during that flood, the water was till this level. In that flood, in that rain, this was the level. It was around 1 meter. 1 meter, sir, quite big, 3 feet around. When there was a flood and all water, there were all plinth work was completed. This fabrication was supposed to be done, but this was going above the plinth by 1 meter. At that point, due to not understanding the flood levels through the town planning authorities and so on, Tata Motors was in a big trouble during the construction phase. Then after that, what they did, the structural department have extended this structure. They redesigned the structure and they extended this like this. So this part was redesigned and strengthened during the construction phase only. And they again changed this and they shifted these heights and so on. Only due to the lack of understanding the flood line, flood level, we can say. So this is so much important point, even though it looks, or we generally don't maybe giving ignorance to that. Even experienced people can ignore this. This happened. Somehow, I'm not blaming anybody because it is not part of the blame. Some of them missed because many times we do start the construction. Yes, there is a plain land, start excavation, do this, that. Because see, flood is something which comes within very rarely case. Flood is very rare case. But from the previous experiences, at least we should understand that. Okay, so this is a very important part, flood line. Corrosive property is something related with the foundation because concrete will deteriorate if there is a corrosive properties to the soil. Foundation design and suggestions are also given by the geotechnical people. Foundation settlement, definitely I know this, I discussed subgrade modulus and this, because permissible settlement we should make sure in the foundation design. Pile design is also generally recommended by the geotechnical consultants. They do also the testing of the piles if there is a weak soil. So do you know how the geotechnical investigation done? Let's say I am having this natural ground level. So they do the core logs Core logs are there at different intervals. They drill in the soil till the rock, maybe 10 meters, 15 meters, 20 meters at certain intervals. And these are the core logs, we can say. Can you see this? So this kind of drilling is done, and then we check sample at each level. So there may be some soft soil, then maybe some murum till this level. There may be some weathered rock, then there may be compact basalt or different proper soil and rock is there within that depth. And once we understand that the geotechnical people study these samples, and then they come out with the SBCs, they come out with the properties of this soil and so on. We will have some session in between, a detailed session on the geotechnical investigation, where you'll understand how is the geotechnical report to be studied and what data we take as a structural engineer in the design. Okay. The next part comes out to be architectural planning. So what is architect doing?
So planning, building plans.
And what points he is considering while planning?
So the user requirement or the client requirement and
Right.
space restrictions in mind.
Ventilation,
Yes.
privacy,
Ventilation, circulation, lighting.
privacy,
Yes, then aesthetic part, functional requirement, maybe we can say if it is a residential building, hall, where should be the hall, bedroom, kitchen, toilets, and so on. If it is a commercial building, then how many office people will be working there, their toilets, the cabins, and so on. So there are a lot of functional aspects, and few we can say we discuss ventilation, light, and something. He is also submitting the drawings to the corporation because
Yes.
we need bylaws. We should do the things as per the bylaws. All that statutory requirement as per the bylaws given by the town planning authorities. He's fulfilling that, and finally he's preparing the working drawings for the civil engineers on the clients. For the civil engineers of the contractors, we can say for the construction and for the structural engineers also, because he is using the drawings. Structural people are using the architectural drawings for preparation of column positions, beams, slabs, and so on. And aesthetic part, one of the important part, because the building should look very good and beautiful, and that is also his artistic part is also putting into that. What is the role of structural engineers? So definitely after the planning, structural engineer is there who is working.
To fix the various dimension of the structural element
Yes.
in optimal way.
The first
So what
part
is the responsibility of the structural?
So the first part is to first of all to study the architectural plan and plan structural requirements accordingly in a most economical way,
Yes.
so that our span can reduce and our steel and moment distribution can be uniform across the structure.
Right.
So we can do placement of columns and beams and spacing according to architectural plan. And in case there is some problem with if there is irregularity or some difficult that needs to be corrected structurally, so so we need to coordinate with the architecture for that.
Right. So
So
yeah, please.
collecting our architectural detailing, then put all the structure unit in economical sections.
Yes. So I can say in nutshell, actually, structural engineer is responsible for the safety of the project, safety of the building. So whatever concrete, steel, or members he is putting to support the, we can say, civil elements or materials, walls, slabs, or whatever, he's making sure that it will be safe and stable. So he's creating a stable structures. He's creating the strong structures, and he's creating the serviceable structures. Can anybody tell me what is meant by stability? So these three S are important, and these three S together is nothing but a safety of the structure. Can anybody tell me what is meant by stability of the structure?
Sir, stability means balancing the reactions that are due to like earthquake, due to dead load, due to live load, or whatever reactions. It may be lateral reactions also due to earthquake forces, or it may be the means vertical reactions that are coming onto the structure due to the dead load or due to live load or due to wind. So for those reactions, whatever system we are developing, so that is stability. That is
Yes. So,
maintain equilibrium equations, getting the
so
equilibrium of the in fx, fy, and moments.
yeah, but yeah, so good. But stability is something he's making sure that the structure will not collapse. I will just give a small example. Let's say there is a one frame like this, and there are all joints are pin joints. Okay, and if I put a load like this, all are hinge joint, hinge joints. What will happen to this structure?
Just tilting down rightward sides.
Sway will be there,
So
sir.
it will sway means it will
Yeah.
almost collapse because all are hinged. So it will just like collapse like this, right? Heavy sway or very much sway that it will almost collapse. It will collapse, right? So what the structural engineer will do to avoid the collapse? Either he can put like bracing like this. Let's say, will it collapse now?
No, sir.
Yeah.
No, sir.
So stability is that avoiding the collapse of the building, catastrophic collapse we can say, or huge sway. Very much huge sway is a collapse, and that means we can. So avoiding the collapse can be said as a stability. In general, I'm not going in too much of the technical details now. We are trying to understand in totality first because this is very you can say holistic approach we are trying to understand whatever smallest details in the structural part designing, and that we are going to learn in upcoming sessions. What is meant by strong?
Sir, resist all the service period, sir.
So it is something that whatever materials we are using in the construction or in the structure, the material should take that load. The whatever stresses are coming in the material, they should be within the limits. So whatever actual stresses coming due to the external loads and whatever material you are providing, it should be within the limits. Strength. Somebody can you mute? Somebody's there. Please mute yourself. Yeah. So strength means something related with the materials. Capacity of the material, we can say it can be said as a strength. Material capacity. Yeah. See, I'm using very small common sense words. I'm really not interested in going in too much of technical terms for this part sessions. Because as a common person, we are trying to understand this holistic picture. And then we will go into the engineering aspects, then mathematical aspects, and so on ahead. Strength is something related with the material capacity. What is serviceability?
What purpose can you fulfill, sir, for which that structure will be designed?
Yeah,
So there should be no deflection or crack
right.
in the during the when the building is in use or the
Right.
intended purpose
Yes.
of the use. So,
Yes. So serviceability is something that to control the deflections. See,
Hello?
many times. Yes. Hello.
Hello.
Yes.
Sir,
Hello.
the cracks and the deflection should be within the permissible limit as per the IS code.
Yes. So many times, see, if you are staying in a bedroom, say, and the bedroom beam is having, let's say, bigger span. Let's say this is a bedroom beam, this is your bedroom, and let's say your beam gets deflected like this. Okay, I'm a structural engineer. I'm say, so will you really happy to stay in this room? Will you really stay in this room? This is a deflection of the beam.
no, sir.
Let's say I'm a structural engineer consultant and I'm making sure that yes, structurally stable, it will not collapse. I'm guaranteeing you. I'm saying that whatever beam steel I'm putting, concrete and everything, it is strong enough and it is satisfying the codal requirements. But okay, it is deflating like this. Will you still like to stay in this room?
No, sir.
Because it is a feeling, giving you scary feeling, because you may feel that it may fail. You are feeling something related with the feelings. You will definitely not like to stay like in this kind of rooms or something. So something related with the feelings, something related with the functional requirements. That is means serviceability, we can say. So the points or deflections should be within the limits. The crack width should be within the limits. Let's say if you take an example of water tanks, if there is a more cracks in the water tanks and there is a possibility of leakage of water tanks, is it really a good sign?
No, sir.
Yeah, even though it is a concrete is
No, sir.
strong, steel is enough, stable, definitely the purpose is not solved. Functional purpose of the water tank is that it should retain the water without leakages. So this is also serviceability criteria. There may be some many criteria like vibrations and on. So in nutshell, structural engineering is making sure that the building will not collapse, structure will not collapse. It should be strong enough. The material should be strong enough, and it is within satisfying the serviceability criteria. All this. So strength we learned in college in which subject? Material strength.
Then is strength of
Strength of
materials.
material.
Yes, strength of material we learned this.
So,
Where we learned the serviceability criteria. It is given in the IS code.
IS code
I 456
456.
2000.
There are many codes. For steel it is 800. For concrete it is 456. And even earthquake code also gives the lateral sway of the building. So what is it? Because in the earthquake it should not sway too much for wind or earthquake. For earthquake loads like this, right? So there are different codes which are giving the serviceability criteria. Strength is given in, say,
In sir, compressive strength or
Tensile
yield strength in
Yes, yes, yes. Yeah,
tensile strength in steel.
where stability is given. Where you learn this? Is it given in codes?
Sir, in mechanics.
Yes. It is not given in any code, in any books. Mechanics, we can say. Mechanics knowledge can be used to make the structure stable. So I would say structural engineer is a person who is doing this stability, who is making sure that the structure is stable. So strength can be taken care by the codes, serviceability can be taken care by the codes, analysis can be done by the softwares, but stability can be only decided by the structural engineer. Okay.
Yes, sir.
Okay, then definitely structural engineering is making sure that he will suggest the material for the building, use concrete, use steel or whatever, wood or whatever. He is making sure creating the column positionings, beam positions, and so on. And finally, he's doing the analysis in the softwares for manual calculations, bending moment, shear forces, and he's preparing the structural drawing, and it goes to the site. So in general, this is the scope of the structural engineer. Then let's is the kind of structural drawings. Try to understand structural drawings is the engineer's language. Drawings is the engineer's language. So we have covered the AutoCAD software because this is very much important part in the any engineering. Structural is also one of it. So basics of drawings, basics of AutoCAD software are very much important in our training, and you should know that. There are many other structural drawing aspects we are going to learn in future sessions. Then comes the construction. So this is a very important part. Construction. What are the key activities in the construction, and who is involved in the construction?
Sir, the client.
Contractor.
Yes, contractor.
Contractor.
Contractor is one of the important stakeholder in the construction process. So he is having a team of laborers, unskilled laborers, fitters, carpenters. Then there are many people actually, electricians, plumbers, and so a team of laborers we can say, skilled and unskilled. There are civil engineers involved, site engineers who are looking after the supervision work, quality work of this. There are machineries like poke lane, compactor, plate compactors, cranes for lifting the heavy weight or heavy objects. So there is a team of people who is working on the basis of drawings prepared by architects, structural engineers, and other consultants. So using the machineries, using the main or the people, team of laborers, these people, contractor is making sure that the construction of the building is done as per the drawings, as per the quality, and within the timeline given by the clients. So this is the construction. You know this actually many times. So contractor and civil engineering team is responsible for the workmanship, material quality, and the specification. It should be done as per the specification given in the drawing. I think all of you have seen any construction site previously. I think so. We have not discussed actually. How many of you are freshers and how many of are working? Just let me.
Sir, I am working.
Just a moment. Amritanshu,
Yes.
you're working.
Yes, sir.
Bijay Yadav, are you working or a fresher or what? Deepak Kumar, okay, you're also working. Bijay? Sagarika, are you there? Okay. Fine. So I think most of you might have seen the sites previously. Then anybody is aware of the structural audit? So once the
Yes, sir.
yeah, construction is done, actually site the society people are doing the maintenance where there is a repairs.
Yes,
During
sir.
the maintenance, what things are done in the societies? Maintenance part.
Yes, sir. Yes, sir.
Yes.
Yes, sir.
Can anybody tell me what is the maintenance?
Sir,
Lift.
sir, in maintenance, what we check is we check about if old buildings are there. So due to tension during its lifetime, so when the structure is subjected to different load, it has tensions. So due to tension, it has cracks and deflections, and there is due to environmental effects, there is creep, shrinkage, and different types of defects and cracks are there, efflorescence is there. So for that purpose there is structural health monitoring of those buildings.
Yeah, that
And
comes in the
in
structural audit. Yes.
Mumbai,
Mhm.
yes, yes, sir. That comes in the this just as in Bombay there are historic buildings that are built by the Britishers. So as they are old structures, so their monitoring is going on.
Yeah. So structural
That
audit
is
is one of the
audit.
part, and general maintenance can anybody tell me? General maintenance, just let's say after 2 years or 3 years. What is the general maintenance?
Sir, paint
Zero-
work,
Yes, painting,
Paint work. Crack. Lift.
filling, crack filling, yes.
crack filling.
Lift maintenance, then
Crack
maybe
filling.
yeah. So leakage, leakage, waterproofing,
Electrical.
Electrical.
yes. So generally that is the general maintenance when the building is new, and after the building becomes old, we have to do the structural audit. So what we do the structural audit in the structural audit? Why it is done?
So to ensure whether the structure is having
Who has
adequate strength or not.
So strength, what is the current strength?
Existing
By
part.
NDT.
Yeah, so current strength means what is the current concrete strength? What is the current, we can say
State
major,
of health.
yeah. Yes. And there is a possibility, see, many times people do the overloading. Let's say there is a living room or bedroom, let's say. Bedroom was designed for 2 kilonewton per meter square live load. And now that person is using the bedroom for the storage purpose. Huge, heavy storage. That means, let's say 5 kilonewton per square meter heavy load. That means it is overloading because it is not designed for 5, it was designed for 2. So we should understand in that audit process, is there any overloading in any room or something? Then deviation of use. So deviation means overloading is also part of deviation. There are many times people enclose the balconies. That means my beam was designed for the railing load, and the people have created a wall on that railing. So, and beam is not designed for the that wall load. So deviation is there. People use partition walls on the slabs in the rooms. Let's say internally they change the interior. In interior they do the deviation. So we have to understand that in the audit, and whether the structure is safe for that habitation. Is there a danger? See, many times in Mumbai or other cities, the buildings are very old, and there is a possibility that they may fail at any moment, in any time. So we should give them that the building is not fit, and please do the evacuation of the building. So that is also used. And many times we can suggest the retrofitting solutions to that building to make it strong, and even suggest the repair methods to increase the life of the structures. So many times we can say that please do this repair work so that life will be increased. So what are the steps in structural audits?
Physical verification is there, visual inspection is there.
Yes, so visual inspection like checking the cracks, leakages, rusting of steel, overloading, and so many things. There are a lot of things in visual inspection. NDT, rebound hammer for checking the indirect compressive strength, ultrasonic test.
Pulse velocity.
So yeah, so ultrasonic pulse velocity test, UPV. Core test, we can extract the core from the building and check it in the lab to actually check the concrete strength. Then there are many tests like chloride sulfate attack and so many tests. These are general tests I'm talking. Definitely this we are going to cover in our training program in the structural audit sector part.
Sir, what is rebound hammer?
Rebound hammer means I'll show you that. This is a rebound hammer. So we can press this rebound hammer on concrete. Let's say it's a column or beam or slab. And there is a number coming in on this, say, gauge.
Instrument.
So this number is related with the strength of the surface strength of the, say we can say concrete. And there is a code, IS codes are there, which are giving the guidelines to relate this rebound number, RH number we can say, with respect to the concrete strength FCK. So there is a one equation given in the IS code, and by that we can understand the surface compressive strength of the concrete. So this is the rebound hammer instrument, okay. Then there is ultrasonic pulse velocity. So in this, actually we are going to learn in a structural audit, but we can say this is a column, and there are two. So this is a line, and this is an instrument. Let's say my instrument, ultrasonic velocity. So the waves are passed through this, and through these waves, actually my waves are passed like this in concrete. Let's say this is my column. This is my column. So these waves are passed, and depending on the velocity of these waves, we can understand how the concrete is there inside it. So quality of concrete can be checked within this UPV test. Okay. Yes. Anybody want to say anything? And there is a concrete core. This is a core testing machine. We can extract the core from columns or beams or whatever we want. And this piece is there. Let's say 3-inch piece is there, circular. Cylinder is there, cylindrical piece. We extract it and test in the lab in we can say UTM. Yeah. And once it is cracks, we get the FCK. So this we test in the lab. So this is core test. Then retrofitting, there are different retrofitting methods, strengthening methods of columns, beams, and buildings, and so on. Actually, we will learn that in detail in audit sector. How we are going to do, how we do in the for the practical project. Yes. And then finally, if the building becomes very, very old, we need to demolish. That is the finishing of the project. Okay. So this is something related with our life cycle. So responsibility matrix, let's understand who is responsible at every stage. Okay. Just a moment, I'll just mute disturbances there. Okay. Okay. Now in responsibility, land is owned by the client, so client is responsible related with the land. Geotechnical investigation is done by the geotechnical engineers, who are basically civil engineers. Architectural planning is done by the architects. Generally, they are profession by architects. Even civil engineers can also do some architectural planning. So there are some projects which civil engineer also can do the planning. Structural framing like column positions, beams is done by the structural engineer, who is basically civil engineer. Structural analysis, design, drawing, they are prepared by the structural engineers, who are basically by qualification be civil. Construction is done by the team of contractors, laborers, and site engineers. So I'm just trying to give you who are responsible at every stage. Maintenance generally done by the client or societies. Structural audit and structural retrofitting is done by the structural engineers. Okay. And demolition is generally done by the special agencies. So this is the responsibility matrix with respect to the life cycle of the project. So if you look at the life cycle, you can see that there are a lot of opportunities for us in the projects, in the civil engineering projects. So that's it regarding the life cycle of the project. So actually today, my aim is to give the holistic picture of the all projects, so that we are going to start our training program from whole to part, and there will be a lot of parts actually in the training program. But don't make sure that you are connecting your parts with the holistic picture. So let's say if you learn the things like this, okay, let's say you're learning a lot of things, but if you don't understand that all these things are a part of a circle, so all these points you can study this in parts, but you should make sure that whatever parts you are learning, they are part of these circles. So you should understand the circle first and then learn these parts. Okay. So that is the meaning of this today's session. You should know where you are working, even though you are working in the parts at some small location, but you should know you are a part of this total circle. So there was one small story, actually, you may be knowing that one person is, so there are three people. There are three people who are working on the site. One person has asked this, there was a labor actually working, mason was working there. One person is asked to this mason one, what you are doing? He said, I am, just lifting the bricks. So he told him that I am lifting the bricks and putting the bricks there. That person has asked to this mason, what you are doing? He said that I am constructing a wall. So he was doing the same thing, but he said, I am constructing a wall. There was third mason who is also asked the question, what you are doing? So this mason has told to that person, I am building a building. I am constructing a building. So these are the point of views of these people. So this person is having the holistic picture. He knows that he is constructing a building, and of that building, he is constructing a small wall of that building. But he knows that he is constructing finally a building, total building. So this is the point of view. This M3 point of view is nothing but a holistic point of view. And this M1 point of view is a part point of view. Actually, this M1 thought process is not useful actually. You should become the holistic person. So holistic thought process is very much important in our life, I would say, not even projects and civil engineering, but everywhere. So this is final my conclusion regarding this session. Please, if you have any questions, please ask.
Yes, sir. One question is there regarding the plinth level.
Okay.
In case we are designing a residential building which have means the porch columns on the means on the edge line, means the eccentric footing is there.
Mm-hmm.
So in case, sir, if we are raising the plinth, means if we are increasing the height of the floor level by 3 feet or by 5 feet
Mm-hmm.
above the natural ground level.
Mm-hmm.
So, sir, in that case, if we are providing the plinth beam below the floor finish level,
Mm-hmm.
so the column which is in the means on the edge, the porch column,
Mm-hmm.
so that in when we will tie the plinth beam, so the rest of the beams can be tied, and the level of that beam will be below that level.
Mm-hmm.
So, sir, is it better to create like this, or is it better to create means the plinth beam at the natural ground level, means 4 inch below the or 100 mm
Ground level.
below the natural ground level, and then build a brick, and then do filling for floor finish level, so that all the beams can be at the same level.
Yeah, so yeah, but I'll try to answer this. But see, whenever you have the question, specific question, technical question, it is better to give me the sketch or drawing or photographs generally. Because what happens, whatever
Okay, sir.
words we
Next time.
use, yeah, whatever
Okay,
words we use, there is a possibility that what you are saying and what I am getting may be different. So see, sketching is one of the best language or drawings or
okay, sir.
photographs,
Okay.
which we can really understand better. See, whatever, if there are four people who are observing the sketch or drawing or photos, they can understand very clearly. But whenever we say ask in the sentences, there is a possibility. I'm talking regarding the specific question, which
Yes, sir.
requires
Yes, sir.
drawings. General
Yes,
questions
sir.
are fine. We can communicate. But let's say you are saying that this is your ground level, okay, and your plinth level is here. Let's say this is your plinth level, PL. So you are saying that do I want to say plinth beam SLNI? So
Yes,
okay.
sir. Yes, sir.
Shall I do the plinth like this? Yeah, SA, this one.
और इसके ऊपर सर ये इसलिए क्योंकि यहाँ पे क्योंकि फोर्ज का जो कॉलम वो जो बीम आएगा सर, जो कॉलम को कनेक्ट करेगा हमारा पूरे उसको स्ट्रक्चर को, तो वो एक लेवल में नहीं, तो इस बीम को या तो नीचे देना पड़ेगा अगर हम, क्योंकि वो पोर्च में वो दिक्कत करेगा
वो बैकअप के लिए ना?
बैकअप के लिए, और फिर नहीं तो वे इसके ऊपर ब्रिक रख के इसको फिल कर दे, इसको मतलब फिल करके डीपीसी करके फिर ऊपर ब्रिक उठा दे।
या ऐसे कर सकते हैं. दिस इज ऑल्सो सी, दिस इज गुड फॉर सी. क्या होता है ये यहाँ अगर रहेगा ना, मतलब क्या बोलते हैं, सो दिस इज जनरली यूज प्लिंथ लेना, बीम नीचे ही लेते हैं यहाँ, एंड वी कैन प्रोवाइड दिस ब्रिक अबव दैट.
ओके
So that अगर if I take this plinth beam above, then this who will retain this? So for retention, I need to provide additional retaining wall because there is a possibility that brick will not take full load. So that case, ये choice generally better रहता है practically. This choice generally.
ओके सर,
Yeah,
ओके
yeah,
सर,
yeah,
थैंक यू सर।
yeah. Thank you. Any questions? Any other questions?
Yes, sir. Sir, one more question regarding the structural safety certificate of old buildings. So, sir, in
Okay.
case there are, if you are getting some cases for providing structural safety certificate of buildings which do not have any structural drawings. So, sir, in that case, how to actually, and we don't even know about what is the reinforcement and what is the footing sizes they have provided, and Means they have just gone for construction from the contractor side. So how to check for that means and provide the certificates?
Yeah, we see whenever you provide the certificates where you don't have any structural drawings or any data, we generally don't give the stability certificate because see you cannot give the stability certificate as such, where you are taking the 100% responsibility of the structure, right?
Yes.
So we cannot give the stability certificate, but yes, we can give condition assessment certificate. Condition assessment. Okay.
Okay.
So where you are only say assessing the condition of the building, and is there, see whatever you points are there, you observing the cracks are there, this is there. You can suggest them the repair solutions. If there is a deflection, excessive deflection, yes, you can mention whatever audit process is there. And at the end, you can say that this is a condition assessment report and the drawings are not available. The, say we can say foundation SBC is not available. Foundation SBC can be acquired actually in the vicinity. And the drawings are not available. That means this is only condition assessment audit. See, structural audit work is something like a doctor, we can say. So if I ask you, if there is a doctor, does that doctor is taking the responsibility of the life of the person?
Yes, sir.
He is not taking the responsibility. Yes. Can a doctor say that he will not die? Even though doctor is fulfilling his responsibilities, he will.
Sir, your voice is not coming.
Okay, wait, I will inform, sir. Just wait for 5 minutes. Don't left anyone. I will inform, sir. Hello, everyone.
Yes,
Hello,
yes.
am I audible? Hello. Due to connection issues, sir has left their session. So, sir told me we can conclude here.
Okay.
Okay.
Thank you. Thank you very
So you
much.
can left. Thank you. Thank you, sir. Okay, thank you.